So with the cell phones, creating them to work as a cell phone with new architectures, I think it was a vision that I started to pick up when I was at Harvard Medical School in later stages of my training. It was evident that the global health problems that we face today, including infectious diseases, would need innovative solutions that mix and match some of the existing architectures, hardware or software that we have, to provide cost-effective solutions. And that's where the thinking was, to really leverage something like a cell phone and its architecture to do some things that we haven't planned when we were talking about a cell phone. One thing that I've picked up is to respect the other researchers and colleagues in the field or in general in science. I think that's very important because we scientists and engineers are very passionate about what we do. That's why we're good at doing those things. But if that's too much, it might be at a level where you kind of think your work is the best and look down on others. I think that's an absolutely terrible way of going above a line. So I'm not sure if I would call it as an experiment, but when I was a kid, I used to really create my own games or modify existing games with new rules so that you could have more fun. So that was one of my biggest fun things to do, just to create new games. And also play with Lego type of gadgets to create new toys out of them. That was really my fun. So one of the nicest things about being an independent researcher is the flexibility of things that you can do with your time. So you have the luxury of choosing a problem that you want to work on and then define the problem itself and then seek out solutions to that. So I think that flexibility of choosing whatever you want to solve for an impact is the most fun thing about being a researcher. So working in an academic institution like a university would mean you need to be very flexible with your time because you will have lots of jobs. You don't just conduct research, but you train students, you give lectures, you travel to conferences. At the same time, you serve in different settings for your university or different panels. So I think you need to really know how to juggle things, many things, and manage your time effectively. So that's one thing that an effective researcher this decade would really need to know, time management. So what I work on is on telemedicine. We create new technologies by leveraging existing technological infrastructure that we have to create really cost-effective, compact, and lightweight solutions to bring more advanced devices into the field, such as microscopes that could run on cell phones, that could attach to a cell phone or be converting a cell phone into a microscope. So the aim that we have with these gadgets that act like a microscope is potentially to diagnose disease with them, including malaria, tuberculosis, or HIV. So if you add them up, unfortunately, we're losing close to 6 million people a year. Tuberculosis, malaria, HIV, together with those simple diseases caused by poor water resources. You're literally causing 6 million a year. So if you had these microscopes or advanced instruments that could look at these signatures of disease or parasites in water or food, you could literally help a lot of people every year. So that's what we're trying to achieve. During my training as a graduate student and after that, my advisors at Stanford and Harvard, they were very influential on how I think and how I approach a problem. So I was very fortunate to work with extremely talented, super nice people at Stanford, my advisors, who were engineers by training. So I really learned a lot of hardcore engineering principles and thinking, critical thinking from them. And after that, I moved to Harvard Medical School, and I was also fortunate, very fortunate, to work with people who had the MD thinking, medical doctor thinking, which is not always aligned to an engineer's thing. So I think I had the opportunity to observe both of them and get most interesting parts of them, maybe to combine them. So being a professor in a university, what most people outside think we do is teach, which is surprisingly common. And I've always, when I say I'm a professor in a university, they say, what do you teach? Which is true, we teach, but it's not really a lot of our time. What we really do is do research and train the next generation of scientists with our research, with our new technologies. So that's not really considered teaching in the classical sense of a high school teacher. So we really do design the solutions that will affect life, that will make life simpler for this decade and the next decades to come. And that's what I think the public is slightly having a misconception of what we do, more heavy on teaching, but it's actually research and training the next generations to make life much simpler. It would definitely be my laptop and any data that I have. Whenever I have the opportunity, I like to tune in a jazz channel, especially in graduate school. I was driving a lot more often. So I like jazz music and international music in general.